Assalamualaikum. Today, me, Rizwana Chaudhuri Raka, with my teammates Shahriar Hussain Imon, Param Guhonyogi, and Allama Bakhtiar, is going to overview our paper on cyberbullying detection from Facebook by NLP classification techniques. Basically, I am going to overview the parts abstract and the introductory part. So, let's begin with the abstraction, that is, unprecedented opportunities for connection and communication have been brought about by the growth of internet and social media. Cyberbullying, a new type of bullying, has emerged as a result. With so many people using the internet, cyberbullying is becoming a widespread problem that affects individuals of all ages and backgrounds. Cyberbullying may have long lasting impacts on victims, from painful messages to harmful posts. Today's method for determining how vulnerable critical infrastructure mostly depends on the personnel of security operations centers. However, dynamic CIs and attack surface evaluation require certain properties that traditional manual and subjective audits lack. In this thesis paper, we propose a method for detecting cyberbullying on Facebook using NLP. NLP is a subfield of artificial intelligence that focuses on the interaction between computers and human language. Our approach involves analyzing the content of Facebook posts and comments using NLP to identify patterns and markers of cyberbullying. By doing so, we hope to provide a more effective and efficient means of detecting and preventing cyberbullying on Facebook, which could ultimately lead to a safer and more positive online environment. Introduction. The employees of Security Operations Center are widely utilized in present vital infrastructure vulnerability assessment methods. Conventional, manual, and subjective audits, however, fall short of the necessary qualities of dynamic CIs and attack surface assessment. For example, certain frequently used tools for determining vulnerability severity, such as the CVSSI calculator, need input from user and depend on qualitative evaluations of vulnerability features such as exploitability, scope, and repercussion. There is a wealth of textual information about cybersecurity, including in vendor declarations, blogs, white papers, and hacker forums. Traditional threat analysis of data from textual source use the time-consuming and unproductive human labor technique. These security analysts are therefore unable to properly utilize the validated cybersecurity information to react to cyber threats in a timely and correct manner. So thank you. This was from my side. Next, Param Guho will be continuing. Thank you.
Hello, this is Param Guhonyogi, and today I'll be covering the literature review of our presented topic. Cyberbullying is a big problem on social media, where people can say mean and hurtful things to others. Researchers have been trying to find ways to use computer automatically identify cyberbullying and stop it from happening. Some studies have used machine learning, which is a type of computer-made program that can learn from examples and make prediction on its own. One study looked at tweets on Twitter and found that combination of users' behavior and tweets context was best for identifying cyberbullying. And the study used a type of machine learning called deep learning, which is good at understanding the meaning of words and sentences. They used to create a computer program that could identify cyberbullying accuracy. Yet another study used combination of deep learning and natural learning processing to improve accuracy and reduce false alarms. They were able to detect cyberbullying with a perfect accuracy of almost 80%. These studies are important because cyberbullying can cause mental and emotional harm to people, and we need to find ways to stop it. Thank you.
Thank you, Param Gohonyogi. I am Alama Buktiar Nafis, and now I am going to present the problem statement and research objectives of the paper. The research problem highlights various challenges and issues in cybersecurity, particularly in vulnerability assessment, data management, and detection of online attacks. The increasing complexity and interconnectivity of systems such as CPS IoT pose significant risks to critical infrastructure and healthcare services. The review suggests the need for advanced methods such as cognitive architecture and artificial intelligence for effective cybersecurity. The review also emphasizes the importance of data gathering and correlation for proactive risk reduction, but the vast amount of data available presents challenges in extracting meaningful information. The review suggests a distributed approach using deep learning methods such as CNNs and NLP models for identifying online attacks, discriminating between abnormal and regular requests, and using multiple concurrent models for system stability. Overall, the literature review provides valuable insights into the current state of cybersecurity and the need for innovative solutions to address the evolving threats and challenges. In the research objectives, according to the research objectives, the use of natural language processing (NLP) in cybersecurity has grown in significance as a result of the requirement to identify and counter potential threats. This article summarizes numerous studies on NLP and cybersecurity. In the first study, it is suggested that when the annotation dataset is monotonous named entity recognition, NER performance can be enhanced by employing BERT transformers. Additionally, it suggests a method for automatically augmenting the training dataset with keywords and automatically labeled named objects. The authors examine the effects of various parameters on the NER system and rate the efficacy of several BERT models. A further paper evaluates the efficiency of LSTM-based neural network models for obtaining cybersecurity-related data. The study compares three different LSTM architectures. In summary, the papers emphasize the importance of NLP in cybersecurity and propose different approaches to improve NER and RE tasks, identify cybersecurity intelligence, and overcome challenges related to limited or varied annotation datasets. These all are from me. Param Guha Neogi will present again on methodology. Thank you.
Hello, this is Param Gunyogi again, and now I'll be talking about how to tackle the issue that we are working on developing on Facebook cyberbullying detection system using NLP. We will compile a dataset on Facebook, post comments using the Facebook API, which enables us to extract publicly accessible post comments about cyberbullying. We will filter the post comments based on specific hashtags and terms related to cyberbullying. The dataset will then undergo processing to ensure that all the data in text-based and to remove any irrelevant information. After processing, relevant attributes will be extracted from the dataset. The text data will be converted into numerical features using NLP techniques such as bag of words, term frequency inverse, documentary frequency, and word embedding. These features will be used to train our cyberbullying detector model, which will be developed using a range of machine learning approaches, including logistic regression, decision tree, and support vector tree. Once the model is developed, we will evaluate its effectiveness. Measures such as accuracy, precision, recall, and F1 score will be used to gauge the model efficiency. We will also access the model on a separate dataset to ensure that it generalizes effectively to fresh data. In conclusion, cyberbullying is a serious issue that needs to be addressed. Facebook cyberbullying detection system using NLP approach is a step towards identifying instances of cyberbullying on Facebook and prevent harm to its user. Thank you for the attention.
Hello everyone, this is Shahriar Hossain Imam presenting the last part of the project, which is methodology, how we implemented our work throughout the project. So to begin the methodology, we first collected the data. Our collection was from the different kinds of internet source, basically from Kaggle. Our dataset is basically text type data, which is in a file of CV file. CSV file. Then it is basically text data which has 40,000 entity to under two different types of classes, basically the comments and their types. So from this 40,000 data we worked with 20,000 of them in order to class the avoid the clash. So after collecting the data, we process the data by different techniques of natural language processing, such as normalization and elementization. And after processing the data, we extract the feature of the data by applying some different types of neural network models. So here is the model development. So we tried several types of models, such as decision trees, logistic regression, and all of them logistic regression gives the greater result. So here is our model evaluation. We have evaluated our model some different types of different stages. So here first model training. So in order to model training, we firstly we before training our model, as I mentioned, we have shortened our data to 20,000, and from there, here we can see their percentage from the bar chart. So greater type of the text is our norm, then the lowest is the support. So after seeing our class distribution, we ran some different types of model, as I mentioned earlier. So here is the most fruitful result outcomes from the logistic regression model. Here is the calculation system of confusion matrix. Here is our confusion matrix. There is basically 7 different classes, which is order labeled by 0 to 6, and here is their numbers and true or false result. So here is lastly the classification result. Here the classification result, we can see that among of 20,000 data, 4,000 is tested, and here is the result of them. So animosity, dehumanization, derogation, none, not given, support, and threatening. So basically there are 7 classes, and all of their result is there. So overall accuracy of the model is now 74. So lastly, we can say that we are still working on our project, and one of the improvement of one of the findings of our project or the novelty of our project is that previous works are made upon 5 or 3 to 6 classes, but we have worked on 7 classes. 1 classes is added, and still accuracy is quite good. We are trying to improve it little bit more. Hopefully we can do it before the final before the submission in the conference. Thank you.